I'm Sherman Snyder, Mastercam AE for MLC CAD Systems, and today we're going to talk about advanced lathe tips and tricks. I always like to start off these events by talking a little bit about myself, just kind of letting everybody know who I am. I am a Mastercam AE out of the Houston, Texas area, and a little bit about my experience. I've been in manufacturing for a little over 20 years now. My experience ranges from aerospace, oil field, biomedical as well. Working for companies such as Halliburton, GE, Rolls-Royce Aerospace Division out of Indiana. But I also have a wide range of other software experience as well. And of course, Mastercam is going to be my favorite in this case. But I want to show y'all what Mastercam has to offer for making your job a little bit easier moving forward, even when it comes down to the basic lathe package of Mastercam. Now, years ago, of course, my dad was a machinist and I kind of followed suit. Started off on manual machines, and back then he told me, you know what, son, imagine the machine as an extension of your arms. And then, of course, a few years later, I wanted to get over to CNC, and I started programming CNCs and running CNC mills. And he came back and said, you know what, before it was an extension of your arms, but now this is going to be an extension of your brain. But no matter what you do, you make that machine work for you, and you don't let that machine work you. And the same rule applies whenever you're looking at, not just running manual machines, but CNC machines and even programming. And so that's where we bring this to the topic of some advanced lathe tips and tricks to kind of improve and kind of streamline some of your processes within Mastercam, even on the lathe side. Now, a couple years ago, I created a video called Getting Started with Mastercam Lathe for MLC CAD Systems here. And it had some really good results, but there were some things that I didn't cover. And I am going to go back and kind of do an overview of the lathe a little bit, but we will start jumping off into some part handling operations, tool library discussions, and some other options as well. So starting off with the lathe overview, let's go ahead and we're going to load Mastercam. And I have my Parasolid file here, the X_T file. I'm going to simply drag and drop that into my graphics window, and it comes in already aligned. We're going to go to the machine tab at the top, over to the machine type group, and we're going to load a default lathe. Let's go ahead and drop down the properties, and we're going to go to the stock setup. And in this stock setup, I'm going to load a left spindle chuck jaws, and we're going to go a little bit further and start loading tailstock centers as well, and we'll be working with the tailstock center within this part. So I'm going to go ahead and go to the properties, and inside of my properties I got a 4-inch diameter stock. If you're not too sure what to do, we can also say make from 2 points, and if I hit O on my keyboard, it automatically goes to the origin as well as Q. If you notice where my auto cursor function is, once I hit Q, it goes to quadrant there. So just kind of using some shortcut keys. Now I had 4 inches in here because I'm most likely not going to get bar stock like this. So I'll say 4. And we'll use margins. I'll add a 100 thousandths to the front and the back of the part. And I'll say OK. Next, let's go ahead and correct our jaws here. Now, I'm going to simplify this just for this particular part. I'm going to have a 1/2 inch width for my jaws. And if you notice, when I hold down my middle mouse button, I got a flat surface. I know the diameter is 4 inches. I'm going to give it a 2-inch radius. Hit enter. And now my chuck jaws will be the same radius of my part stock here. Let's go over to our parameters, and I'm simply going to say from stock so that it knows to shift from that point here, the high point of that radius, to my stock, and I'll give it that grip length of a 1/2 inch. We can preview the boundary. You know what, let's say top view. There we go. And that looks good. I'm going to green check on this, and the last thing I want to do inside of this stock setup, we're going to go to the properties for the tailstock. Now, I already have these predefined from a previous operation here, but I'm going to leave this for default. I got my diameter, center length, 60-degree point angle, and the 12 inches away from my WCS. If I was to preview this lathe boundary, kind of zoom out, we can see our tailstock over here to the right. I'm going to hit escape, and let's just green check out of this. And then we're going to save our part. At the end of the day, save is your friend. So, the next thing that we're going to do inside of here, we're going to go to the Lathe Tool Manager in the Utilities group. And instead of loading a bunch of tools in from the default library, I actually have a library with the tools that I want to use for this particular part. So I'm going to go search for my library, and you'll notice the libraries all have a .tooldb extension to them. So let's go here, and I'm going to look for my lathe tools. I got my lathe tools.tooldb. I hit open, and with my filters off, you can see all the tools that I do have in this library. I'm simply going to highlight and drag all these up. I can also hit the up arrow here, or if it's single tools, I could even double click and have it add. Now, the same thing applies the other way. If I was to create a tool here, no matter if it was 3D or a simple 2D tool, I can also drag that tool back down into the library and save this for future use later. We'll talk a little bit more about that later. For now, I'm going to green check OK, and we're going to go ahead and set up some basic operations here. So the very first thing I'm going to do is create a face operation, and I got my tool 1. This is going to be a CNMG, and I'll just say face part for my comment. Now I'm not going to worry about any feeds and speeds, but I am going to worry about my parameters here at the top. I'm going to go ahead and let it use the stock. I do want to finish at Z0, and I want to do a rough step over of 50 thousandths, so we can at least see some kind of tool paths here. And I'll just green check OK. So right off the bat, Mastercam already knows where the stock's at. It makes this face operation super easy. The next thing I want to do is I'm going to go over to, we're going to do a rough OD. So let's see, I'll do a can cycle rough. This is going to give me my type 1 rough operation here. Type 1 being always climbing as it goes back. And I'm going to say I want to rough everything from this location to here. And we'll green check OK. Now for this, I'm still going to use the CNMG. I'm going to say turn OD for my comments. I like giving it comments, especially when it comes to the can cycles. And I'm going to go to my can rough parameters. Now as you see here, I can see my Z stock, X stock, and it also gives me a preview down at the bottom that we can always look at. You'll notice that if I change the R, I hit tab, it updates the R value. So you get a quick view of what you're going to get inside of your output. In this case, it's showing the 2-line new standard code for turning can cycles. Now, you do have plunge parameters here, and to be honest, I really don't want it to plunge in any areas with this tool. So I'm simply going to leave that alone. But I do want to adjust the lead in, lead out for this particular part, specifically because I got this chuck jaw here. So by doing so, let's go ahead and shorten this up. I'm going to go to my lead out, and I'm going to say I want to shorten this by, let's say, 0.6. Give it 100 thousandths more than that chuck jaw. If you want to display your profile, you can kind of see where it's going to end here with that little line. I don't want to save that geometry though. I'm going to green check OK. So right off the bat, we have a tool collision with stock. I'm going to say continue. We're going to look at some of these parameters here. So just below that, I got extend contour to stock. Now, without this option, Mastercam does not know where that stock's located on this can cycle. As you see here, it's skipping quite a bit. So this is going to be an option that we want to turn on for sure. What you'll notice is that the X and Z value change here when I do so. So just an example of how this does a live update, not just after you do the preview, but even before you generate this toolpath. So now when we go back, I got a nice clean can cycle, and I'm going to go ahead and save my part. Next toolpath we're going to talk about is going to be a rough for this particular operation here. And for this, I actually have a button tool loaded. Let's go ahead and do we'll do a dynamic rough for this, just to see what this toolpath looks like. So you'll notice right off the bat that I'm actually running off of a solid, and I am in my solid chaining manager, and it creates that cross section for me. I'm going to go ahead and select this particular area on that cross section for this undercut. Now, Mastercam does need to use a tool as such to do the dynamic rough. So that's why I have this button tool loaded, and we'll just say dynamic turn. I can type today. Again, I'm not going to worry about feeds and speeds. I'm more focused on the parameters right now. And for this particular step over, let's say we'll do a 10% step over, 10% toolpath radius, and I do have some stock being left behind here. I'll just say 10 and 10 for X and Z. And you know what, let's go ahead and look at our plunge parameters right off the bat, and you'll notice that it automatically goes to the plunging of this particular area. And let's go ahead and green check OK on this particular toolpath. So now I have a dynamic toolpath being done, and of course I can edit if I want to go forward or back or zigzag back and forth. But let's go ahead and backplot this, just kind of take a look at what this tool is doing. And we'll speed it up just a little bit. And we get a nice high-speed turning operation for this OD to rough out that undercut. All right, so I like that dynamic turn there. I'm going to go ahead and save this particular one. And next, what I want to do is actually finish this OD, and I want to skip over this particular area. So we're going to have to plunge into this area, skip over the secondary one, which lets me know when my chain ends, we have to end on this particular diameter and then do an extension, which is fine. So what we're going to do is go to let's use a longhand finish code here, and I'm going to select the front of my part to this diameter. Inside of this, we're going to use our V and MG. I want to make sure that I have plenty of clearance when I drop down into that area. I'll just say finish OD. We're going to do finish parameters. Of course, right off the bat, plunge parameters need to be adjusted. But I also have my lead in, lead out options here. For my lead out, I'm going to have to extend this, sorry. But you'll notice I got these yellow boxes. At any time, I can right click in a yellow box. I can say I want to do a distance between 2 points. And in this case, I could say from here to there is going to be my extension. Now, remember, I went back negative 0.6. I could say minus 0.6, hit tab, and you see the amount for my extension is actually going to be 1.4. Let's green check on this. And there we go. It's lifting up right at the end there, finishing the OD. So the next thing we're going to talk about is let's do a plunge turn actually for this particular diameter. Now, before we do the plunge turn operation found in the general group here, I most likely want to take advantage of having this tailstock, and the reason being is because when I do the plunge turn, I actually want to utilize both directions just to keep my tool engaged into my part here. So what we're going to do here is look at some of the part handling capabilities that we have. So what I'm going to do here under my part handling is I'm going to take the tailstock operation, and what you'll notice is that there's an auto setting within this operation here, as well as a transferred position. Now remember what I said about the setup. Whenever we done the setup, I told it that we were 12 inches away. So by using the auto setting, Mastercam already sets the 12 inches away where it's located right now. And I'm going to go ahead and just transfer this to 0. So we're going to do it in advance. And you'll notice that the tailstock now comes up against our part, and we can now go to our General tab and look at that plunge operation. So when I open up the plunge operation, it's asking me for a chain, and I'm going to go ahead and say OK and select my chain. I'm going to select my grooving tool to plunge with, and I'll give it a comment of plunge turn. And I'm going to go right to my plunge turn rough parameters. Now inside of here, I'm going to set my depth of cut for 50 thousandths and maybe my minimum for 20. As you see here, I'm going to zig negative. As I plunge from the front, I'm going to go back. I can also do a plunge positive and zigzag that way, or do a one-way, whether it's positive or negative. But again, zigzag negative. And I'm going to go right to my finished parameters. I'm going to set my tool deflection just for 0 at this moment. And you see that I have a stock clearance of 30 thousandths. I got stock leaving behind here, and X and Z both at 0. And I'm simply going to green check OK. This is a pretty familiar path to me, especially when it comes to some of the oil field products I've dealt with, such as flanges with a nut relief that you had to dig out a lot of material there. And if you're curious about what tool to use, I would say reach out to your tool vendor, whichever tool vendor that you prefer to use. I know Samic's got some tools for this as well. But here we now have that plunge operation, and the next thing I want to do is actually move this back out of the way, because I have to come down into the part. I need to drill it. I'm going to have to bore the ID, and I can't have this tailstock in my way. So we're going to go back to that part handling operation here for tailstock, and you'll notice that automatically it's at 0, and it's setting it for 12 inches by default, just because it knows what we done in the previous stock setup when we started this part. So I'm going to go ahead and green check OK. If I zoom out, you notice that it sends it back to the 12 inches here. So for now, I'm going to go ahead and say top view and fit, and bring the part close up on our screen again. So the first thing you're going to notice here, if I go to my Lathe Tool Manager, I actually have a boring bar and a drill already located here inside of the library. So I'm simply going to green check OK. Now, before we drill the ID, I actually want to be able to see the inside of my part, not just whenever I'm looking at the wireframe. So the very first thing I'm going to do is go to my planes. And inside of my planes, we had this section view that we could look at. And you'll notice that when I go ahead and turn the section view on, it doesn't split the model. What we're going to have to do is go to our View tab and make sure under the graphic view that that section view is turned on. From here, I'm going to go back to my toolpaths, and we're going to go to the Turning tab, and under the Turning tab, I'm going to create a drill operation. We have our drill located here, and I'm going to say drill ID for my comment, and I'm simply going to go to the parameters for this drill operation. I'm going to use the depth option and select the back of the part. I don't know what the angle is of this particular drill out of the library, but I do know how much stock I got on the back face, which was 100 thousandths. I'm simply going to say I want to pass my drill by 50 thousandths more than the 100 thousandths we had. I can green check OK, and you notice that the stock has been removed all the way through. I'm going to go ahead and put it in my top view, fit, and let's save our part. So next, we're going to go ahead and create a quick operation for boring the ID. I'm going to use the can cycles, and we're going to zoom in on this particular chamfer as well as the ID itself. And I know I got 100 thousandths passed. I'm going to go ahead and select my boring bar. Let's say rough ID. I'm going to go to the can cycles. I can adjust my depth of cuts. I can adjust the exit distance for my R retract. And I'm also going to go into that lead in, lead out. Let's extend this lead out by, I'll say, 1/4 inch. I want to make sure I go past the end of the part here. And I'll green check OK. We're going to use the extend contour to stock option. And I'll green check again. So now I got a rough can cycle. And we're going to go ahead and create a finish can cycle for the ID. The can cycles being the one with the little recycle symbol next to them here. And you're going to see why I actually like putting comments here inside of Mastercam. So when I go to my can finish parameters, right off the bat, I can see the turn OD. I can see the rough ID as well. The reason I label these is because it makes it a little bit easier to see which operation is which. Now for a finish can cycle, there's no geometry I have to select. I can simply select my rough ID, green check, and I have a finished can cycle for this particular ID. So this is one of the ways that Mastercam kind of help streamline and speed things up. If you prefer can cycles on the machine, it will definitely make it easier for going back and picking the finish operations. You don't have to pick no geometry. But for now, I'm going to go ahead and say top view, fit, save my part, and we're going to move on to drilling the holes on the OD here, these little angled holes. I actually want to go over to my view tab and turn off this section view. With the section view turned off, I can see all holes on this particular diameter here. And what you'll notice is that I have the C-axis drill and cross drilling options within Mastercam for the lathe side. I want to take advantage of some of these options that I have under the milling side for drilling on this OD. So I'm going to go to my milling tab and I'm going to say drill under the 2D operations. And I'm going to zoom in. I can hold down Control and click on the actual surface itself, and you'll notice that it automatically selects all the other features around the outside. I can green check OK, and then from here we can look at some of these tools that we actually want to have within this particular part. Now, you don't have to go through the mill tool manager. I can actually create a tool here as well by right-clicking in this box, create a tool. And as you see, I have my end mills, face mills, all the way down to my hole making tools as well for my drill. This particular hole size is a 1/8 diameter hole. I'll leave these by default. I'll keep this pretty standard to what I like to use, somewhere between 130 and 135. And I'm going to click next. And here you can number your tools. You can label it whatever you want, as well as give a manufacturer name, EDP numbers, or anything else you need. I'm going to say finish for this particular tool, and I'll say drill OD holes. For my parameters, I got a drill counterbore. For my axis, I'm going to select my 4th axis here. For our hole segments, we'll go ahead and bypass this. We're going to go to our linking parameters, and we're going to start looking at some of these other options here that we have. Right off the bat, I want to tell it that I have a 1-inch clearance. Notice that all these are incremental here. I'll say 0.1. And for now, I'm going to say 0 and 0. I want to use this calculate depth from top of hole. And I'm simply going to green check OK, just so we can see what's going on. Okay, and I will have to go back and adjust some of these parameters, but with that adjust depth from top of hole, we can see that we're going 0 to the top. If I was to turn this option off, you can now see that Mastercam is trying to push it through the bottom. So you have the choice of going to the top of the hole, to the bottom. Now we are also running on that 4th axis. I'm most likely going to want to switch this over to a 5th axis operation to get the tool to tilt over as needed. Another thing you'll notice is that we have this line going from one point to the next, And it's fine. I know in the output we actually get a rotary motion, but what if you want to see it within Mastercam as well? If I was to go inside of these parameters, the very first thing I want to do first is go to my tip compensation. I want to make sure that I'm breaking through the bottom of that hole. And having the option off in our linking parameters, for this, calculate depth from top of the hole, having that unchecked in the tip comp will allow Mastercam to read that complete solid going down inside of the hole and assure that I'm breaking through no matter what angle I'm at. But we're going to talk about this automatic linking feature here. And with this automatic linking feature, I can now go under my parameters and give it a safety zone. And inside of the safety zone, I could define the shape at which I want to allow Mastercam to have the safety zone here, of course. If I was to say cylinder, and I select my solid, Mastercam is going to give me a default cylinder that we're going to be working with. If I was to green check OK again, we can now see Mastercam actually has a rotary motion. And again, notice the color change as well, because this signifies that we have a feed motion going on. So from here, I'm going to go ahead and, again, we'll put this back in my top view. I'm going to set this for fit, and I'm going to save my part. We're going to talk about the part handling operations within Mastercam. And I actually have a few different files I'm going to bounce back and forth between just because I like how the stock is already set up and how it automates these features. But let's go ahead and jump off into that and get started. First thing we're going to do for our part handling, we're going to discuss the basic stock flip operation. Now, I also showed this in the previous video that I've done, but we're going to go ahead and talk about it again. And we'll break this down in a little more detail. So right off the bat, we can see what active spindle we're working with. In this case, I got my left spindle. I have a geometry section here, and I can transfer this geometry if I select it, which is actually what I want to do. So I'm going to take the select button, and I'm going to select my geometry just by dragging a window. I have the option to blank out the original geometry, which I actually want to do as well. I don't want to see both of the parts here inside of my file at the same time. Next, under our levels option, I can keep it on the same level as far as the geometry being transferred. I can copy to a certain level, or I can offset that geometry to be 10 levels more than my current level. In this case, I'm going to say 20 levels more. When it comes to the stock position, the very front of our part is already Z0, and by default this is automatically populated. Mastercam has the transfer position and needs to know the new 0 of my part, which if I was to flip my part around, I'll say select, would be the very front of my part here, -573074. The original chuck position is already there by default, and Mastercam needs to know the final position of this particular chuck. I can use the select option here, and you'll notice that automatically my part flips around, and I can either say Q on my keyboard, or I can drop down my auto cursor function and say Q here, or quadrant, excuse me, and I could tell it that I want to chuck onto that particular diameter here. So now we can see the finished diameter with a -2 back in Z, and I can green check OK. So if I was to put this in my top view, you can now see that our chuck is up on that area where I selected. Our part's actually down inside of the spindle. We have a little bit of stock here on the end, and my part is completely flipped around. So if you need to see the previous part, you can also toggle through your operations, and you'll notice as we toggle through the stock updates as well as that stock transfer here. I'm going to go ahead and put this in my top view. We'll do a fit, and I'm going to save my part. I have a stock flip being done in this one, and you'll notice in my stock setup we had that tailstock defined. In order to do a stock transfer, I don't want to have my tailstock in the way, so I actually have this other part file here called stock transfer. What you'll notice is that I have a right spindle already defined. And inside of my right spindle, if we look at the properties here in the stock setup, I can see that my chuck from this point is 15 inches away. And it's also preset for a 4-inch diameter. We're going to go ahead and create the stock transfer option here. And you'll notice, just like the stock flip, I can select my transfer geometry. I'm going to offset this by 20, just as we did before. And Mastercam already has a lot of these options automatically populated by how we set up the stock setup. What it doesn't know is what my pick-off position is going to be. I'm going to go ahead and select my pick-off position. I could say quadrant, since I didn't say from OD. And I can select that quadrant point and get my Z value as well as the D value. I'm going to green check OK, put it in my top view, and we're going to fit this to the screen for my right spindle. So now that our part is loaded into our right sub-spindle here, I need a tool that can actually machine on this right face. If I go to my Lathe tool manager, I'm going to go ahead and select my OD rough, simple 2D tool, and I'm going to drag it into the upper library here, or the turret that we have. And I'm simply going to double click. Now, whenever you're selecting tools for your right spindle, you need to make sure that you go into your setup for the tool. And here you'll see an active spindle, whether it's going to be the left or right. You'll also see the mounting position being done as you toggle between the two. What this is going to let me know is whether we're going clockwise or counterclockwise, depending on the mounting position as well, and the tool setup itself. So again, always pay attention to this little picture here, and if you're unsure, we can green check and we can actually draw this particular tool. I'm going to hit escape. I now have this tool for my right sub-spindle here. And I want to go inside of this and actually change my tool number around. I'll call this one, we'll say tool 11. That way I'll have two tool number 1s there. And there we go, 1111. And I'll green check OK. So now whenever we're working on this particular operation, or this particular spindle here, I'm going to load a finish for this. And inside of our finish, I'm going to go ahead and select this sub-spindle tool. Now you'll notice at the very bottom our axis combination. See how it changes from the lathe upper left to a right upper. And I can also go into my right upper and I can create a new plane here. We want to use this one for maybe G54 and our right upper for G55. I can select my Z here to be the end of this part, and that's the new location. I can green check OK. And I'll say sub-spindle face for our comment. And inside of our face, I can say finish Z here, rough finish operation. That looks good. And I'm simply going to green check OK. So now we have our sub-spindle being done for the facing operation. So I'm going to go ahead and put this in the top view and fit to my screen. And we're going to move on to another part handling operation within Mastercam. We're going to talk about the Pickoff pull cutoff operation, or the POCO event here. And the Pickoff pull cutoff operation within Mastercam is automated to actually have the chuck open up, the bar stock advance forward, chuck clamp down, spindle, sub-spindle advance forward, and then the cutoff tool will actually come in and part it off and have the sub-spindle retract back to the home location. Being that my stock isn't set up on this one, I'm going to go ahead and go over to my long bar stock file here. And we'll go ahead and save this one. Save as your friend. And inside of this file here, you notice that I already have the ID board and everything, just as we did before. But we're going to take a look at the stock setup that we have here. Now again, you notice that I'm not using the right spindle stock. There's no definition here. I'm letting Mastercam migrate everything over to my sub-spindle as we do the stock transfers to the right spindle. But I still have my right spindle defined. If I was to look at this, inside of my properties, you see I still got the 15 inches and the 4-inch diameter. Now, inside of the left spindle for our stock, I did make some adjustments to this here, and I do have a 30-inch margin for our bar stock behind our part. What we're going to do here is utilize that part handling operation for the pick-off, pull, cut-off operation. And right off the bat, you notice the operations to program at the top. I could do a pick-off, cut-off, I could do a pick-off, or a simple bar pull as well. In this case, I actually want to part it off and leave my main spindle with stock in order to recreate another part and get a nice cycle going between my main spindle and my sub-spindle. I do, however, in this case want to select my geometry that I want to transfer over. I'm going to translate this over to, well, by default it says 100, so I'll keep it 100. Next, I can create a spindle name view, and I can also generate a pick-off spindle stock if I'd like to. What we see here is we have the view name, spindle view, left face, and then my right face. I'm going to go ahead and select my left face. We're going to go to the lathe finish part, and what you'll notice here is what it's looking for. So if I say from geometry, it's picking up my overall length. This is going to come from my model. Mind you, this is also coming from that stock setup that we created. If I was to say Z pickoff, Mastercam is going to want to know where I am picking off from, and in this case I'll use the previous quadrant point and let it pick off from negative 3.73074. My cutoff width, if I know the cutoff width, I could put it in here, or I can also click and go select my cutoff tool, which will populate the same field anyway. For my X coordinate, I could say from stock, my face stock that I want to leave behind for my main spindle, I could tell it 100 thousandths. And notice how it populates this automatically based off of what I've had in my stock setup as well. My back face stock automatically populated 30. I'm going to go ahead and say maybe I only want 20 thou on that back face. And I'm going to green check OK. Inside of our Toolpath Manager, you notice Mastercam has automated this process for that pick off, pull, cut off. If I was to put this in my top view and we could step through it, we could actually see the process. Our jaw opens, clamps, pulls the bar stock, gets parted off, and then retracts back to the sub-spindle home location. So next, we're going to talk about some tool libraries within Mastercam as well, and how this can help you kind of streamline some stuff and speed up your programming process. So when it comes to Mastercam tool libraries, as you've seen throughout this this presentation today, I've actually been pulling in libraries instead of creating these. Now, I'm going to go ahead and go back to Mastercam, and with our previous file that we have here, you notice that I was able to bring in tools from a different library as well, and also go back and edit them. If I was to bring in any tools, doesn't matter what the tool is, and I add them to my library or inside of my turret, I can go back and use these particular tools inside of another file if I like. Or let's say that you're starting from scratch and you want to actually build your library. Between the upper and the lower window, and if you don't see the upper and lower window, you can go to the right corner here and you either have your part tools, which is going to be what you're working with, or your library tools. You can turn on the option for both. But what you'll see is I have a create new library. As you've seen in this presentation, I've been using the select from a different library. And I can also import tools from a Mastercam file as well. If I wanted to create a new library, I can create a new library there. I'll call this, we'll say MLC new lib. And I'll save this. And you'll notice that I start with a fresh instance for this library. And I can simply drag any tools that I want to be in that library for future reference. When I green check OK, it's going to ask me, confirm changes made to library, and I'm going to say yes. That way, when I go back to this particular library, the tools will always be there. And anytime you make a change to your library, it's going to allow you to pull these tools in later, and it will also prompt you whenever leaving, saying, hey, we have a change to our library. Is this what you want to do? Do you want to save this for future reference? So moving forward, I'm going to go ahead and green check on this, and I want to talk about some other options within Mastercam. So next, we're going to go ahead and jump off into some of these little tips and tricks to kind of help improve your programming time down the road. So the file that I have loaded here, just some basic geometry. It's the cross section of the previous part file that we've been playing around with. Let's say that you have some geometry, doesn't matter whether this is the mill side or the lathe side, but you have some geometry you want to use for future reference. Maybe you have an API thread that you like the way that it's designed. You want to be able to go in there, select angles, or even on the mill side you have a bolt pattern that you want to import into another file. Maybe this is a connection to an air hose of some sort, or some kind of pressurized connection. We could take this geometry and actually add it to another file. So by using the save sum function found under files, I could select the geometry that I want to export, and you'll notice that I can export this out in many different ways. I can do it as a step file, a drawing. In this case, most likely it would be a drawing or a DXF of this wireframe. But if you have solids, you can also bring them out as that as well to use for future reference. Now, I'm sure most of y'all may have seen that option already, and typically in this class, or even in the essentials class, whenever I'm going over this is something I bring up. What I also want to talk about is what happens when you have operations that you want to use for future reference as well. So in this case, let's start by going to the Machine tab. I want to go over to the Machine type group, drop down the gallery for lathe, and I'm going to select that default lathe. Once your machine group is loaded for this lathe, of course I can always go in there and say stock setup. I can define my stock by 2 points, say here to there, and of course I remember it was 4 inches, right? But we're going to use the margins again. I'll say 0.1, 0.1, and I'll hit enter here. I'm not going to worry about the chuck jaw setup. I want to focus more on importing in this particular operation that we can use. The very first thing you'll notice is inside of my tool manager here, I do not have any tools. And if I was to actually go back to my folder that I have my files in, I have this import file which we're going to be using. What I'd like to talk about is inside of the tool manager, if I right click, you also have the import option here. And I can go find the file. If I say remember this file, it's going to remember this location where where it resides at. But there's also another way to do this, which is my preference. I can hold down my left click and I can drag that file right there into my tool manager. And it will automatically select the location. I got remember this file. And I could select anything I want within this operation. So in this case, I can say I want to do a face operation. I don't have a tailstock loaded, but if I did, I can grab that. I can grab a rough can cycle and finish operations as well. I can plunge turn. I can do anything I want to do here. I'll just say we'll bring in those operations, and I'm holding down control as I select them. You can see the green check mark on them. It's going to tell me they've been imported successfully. I can say OK and X out. If I go to my Lathe tool manager, I can now see these tools have also came in as well. And if I was to go back to my lathe face operation, I can see everything came in from the previous operation. I can simply green check OK, and I got a face operation. Now what you also notice is the face operation didn't require any geometry because it already has a Z0 that you're selecting. The can cycles for the rough here, on the other hand, do. And you'll notice that I have my 3D tool here, as well as my V&MG for the 2D tool. What I want to do is select my geometry first. And I could do that by selecting the geometry group, or the geometry option there under this rough can cycle. I can right click here and I can add a chain. And I can tell it that I want to machine everything within this area. From here, I'm going to open up my parameters, and I'm going to go ahead and select my V&MG. I'm going to tell it this is a rough OD type 2. And if you don't know what a type 2 rough operation is, before I said a type 1 rough operation constantly climbs up going back. A type 2 operation will actually allow you to dive off into cavities and climb back up. And the difference on the two operations output wise, you will see is how you approach your part. For now, I'm not going to worry about the output. We're going to discuss some more of these parameters here. And I'm going to look at the plunge parameter. I'm going to allow it to dig down into that area. But I also want to extend my lead out for this particular geometry. And in this case, I could do a distance between 2 points. I could say here to there. Maybe make it a nice round number. 1.5, and I can green check OK. And green check OK again. Inside of my parameters here, you notice that I have that extend contour to stock. So we are reading towards the very top. This allows our retract to come back up towards the top for that initial cut. Definitely want to make sure that I'm clearing everything. And then of course coming out here, digging down, and you see the final retract going back to the stock again. For my finish, you'll notice that this is a long hand cycle. I will have to select my chain, just as we did previously. I'll green check OK. But I also have a little bit more control over this particular operation. With the lead in, lead out, I can select to extend the start of the contour. And I can also select how I want to approach my part, which I'm leaving this by default. I do, on the other hand, want to extend. We've done it 1.5, so that looks good. I'm going to have a 45-degree retract off that OD. And of course, I need to make sure that my plunge parameters are set. And I can green check OK. Now, to be honest, the only thing I'm really doing in there is extending my contour here. Had this came from the very same connection and I was adding this connection to another part, I could simply select my geometry and regenerate. If I want to do my plunge turn, we'll make an example of this and I'll say add. And without doing anything, I'm simply going to regenerate this toolpath. And now you notice that I didn't do anything parameter-wise. I automatically brought the toolpath in and let it process the parameters just like I like them. For my drill operation, I'm not even going to select anything. I'm just going to, okay, let's see. What am I missing here? Drill, negative, and there we go. So I just went ahead and regenerated. I didn't mess with any parameters. I must have clicked on something a little off there. But this is a way that you can bring in these particular toolpaths and actually kind of fast pace your programming and assure yourself that the parameters from a previous toolpath are coming in, and they're parameters that are safe, parameters that you like, and it makes things a little bit easier down the road. Now, there are other little options here and there that I'd like to discuss as well. And one of the main options I like to talk about whenever I think of any tips and tricks is a very basic function found when you right-click called Toolpath Editor. To elaborate a little bit on this particular Toolpath Editor option here, I mentioned API threads just a few seconds ago, and one of the things I like to do on API threads is when I'm finishing the OD, I actually like to rough the surface up a little bit, so my finish on the threads on the thread location will actually be like 20 thou per revolution. And the reason being is because I'm coming back with a topping insert, and this allows, not just me but the operator visually to be able to see, when that topping insert hits that surface, it's definitely going to clean up that rough edge and give him a visual to let him know exactly when he is actually at a certain location. But the problem here is as I go over this thread area and then I come to the back of any kind of API thread or any other surface that we, maybe this surface here is a seal surface and we have to slow down. This is where my toolpath editor comes into play. Now, as primitive as it looks here, you'll notice that I have this little red dot and I have a position for the point. If I move this dot to 0.2, the red dot moves down. But we have all these functions here. I could delete sections, I could delete points, delete passes, cuts. I want to function on the left side. We'll bypass the move point option and we're going to look at the edit point options here. When I open this up, we can see that we're in a rapid motion. I can see if I have cutter comp on or off, and I can also see my coolant options as well. We'll go ahead and go to a feed motion here, and we can see I got 5 thou per revolution. And this is just the default that we have selected. But let's move to a surface that we might want to maybe slow down even more. So I'll go to 0.12 actually. Remember, it's always traveling to the point shown. So in this case, 0.12, let's go up a little higher, right there, 0.13. I'm going to edit this point. I'm going to tell it that, on this one, I want to go really slow. We'll do 2 thou per revolution. If I go to my next point afterwards, 0.14, and I go back to my edit point, you'll notice that it's still modal. I want to change that back to 5. I can add any kind of rapid motion. I can change whether I want to go between inches per minute, inches per rev, and I can shut the coolant off if needed. I can also add stop options too. But right now, I just want to discuss the feed rate. What we're going to see here when I say, let's go ahead and green check, is we get this lock option that we see here. Whenever we do this, if I try to regenerate, Mastercam will not regenerate this toolpath. It is locked, and the only way to regenerate is to unlock. I will give a pointer here and say, in times like this, I like to add comments for myself. And in this comment, I will say edit made to, I don't know, we'll say sill area, right? And I can green check. Now I'm going to drag this above that lock operation, and I'm going to ghost this out. So this is a little trick I use whenever I make edits with a lock on it. I'll add a manual entry and I'll ghost it out so it doesn't come out in the output for the operator. But if you ever need to go back, say it's 2 years down the road and you want to see what happened in this lock operation here, you can always go back and check your notes for yourself. I also do this, oddly enough, for revisions. I'll ghost it out and show the many edits or whatever edits or revisions for the part that I actually have for my part file here. So other than that, that kind of wraps up the day. If you have any questions, feel free to ask. And feel free to stop by mlccadsystems.com or mlc-cad.com for more information. We do have a knowledge base on there as well. And as well as our YouTube page, which supports both the SolidWorks and the Mastercam side and the Markforged 3D printers as well. We do put out a lot of content on there. But again, if y'all have any questions, feel free to reach out to us. Thank you.